Hi, everyone, and welcome to our March meeting. Tonight, we welcome Carol Higgens, NASA Solar System Ambassador and member of the Mohawk Valley Astronomical Society, located in the vicinity of Utica, New York. This group holds their monthly hybrid meetings at the Waterville Public Library. After much funding and donations, the library provided them with a roll-off roof observatory for their club's 16-inch Meade LX200 telescope. Carol is a graduate of the Empire State College, having majored in economics and business management. This led her to an extensive career in software technical support as a VP and director of an application software development and as a product manager. At present, she voluntarily instructs unemployed and transitional career women in computer skills under the sponsorship of a nonprofit organization. Growing up, Carol's exposure to the televised segments of NASA's Mercury program fueled her interest in becoming a NASA JPL Solar System Ambassador. Given the recent news surrounding the ISS, the topic of this evening's lecture could not be more timely. Please give her a big welcome.
Hi, everyone. Here, I guess I need to share my screen. Hold on a second. Let's see here. Need to share sound, share my screen. Whoops. Share. Okay. Can you see it?
Yeah.
Okay. So thank you for the introduction, and thanks everyone for coming to tonight's presentation. We're going to be talking, as mentioned, about the Commercial Crew Program and how robotics plays a role. So let's see, let me get my pointer going. Oh, for Pete's sakes. Okay, so what we're going to cover tonight, we're going to start at the International Space Station, because it turns out that if it wasn't for the ISS, there wouldn't be a Commercial Crew Program. And then from there, we're going to move into the program itself, talk about the two partners with NASA and talk about their technical solutions of getting people back and forth to the station. And then we're going to switch back to the station and talk about what it's like to live there and why do we want to do research and how robotics can play a role. So let's go to the space station. So what is it? Well, the space station is a large spacecraft orbiting Earth, and astronauts live on board, and it's a very unique research laboratory, and we'll explain that in a couple minutes. Very strong partnership between 5 space agencies, NASA, European Space Agency, and the space agencies of Canada, Japan, and Russia. It's a very strong example of awesome, not just a partnership, but sharing information and doing things for the good of the world, really. So it's the size of a 6-room house. It has 18 pressurized modules. These are the modules in various places. If you brought it down and set it in a football field, it would cover the whole field. It has 8 docking ports so that visiting vehicles can dock. It has over 50 computers and over 350,000 sensors to monitor all of the systems and so forth. So you can do research inside the space station, but you can also do research outside, and we're going to talk about some of those platforms. So where is it? Well, it's orbiting Earth. It's about 250 miles above the Earth. travels 17,500 miles an hour, which is about 5 miles a second. So boy, you could really get someplace in a hurry if we could do that on Earth. Makes one complete orbit of the Earth every 90 minutes, which means it switches from daylight to darkness every 45 minutes. And every day, as a result of that, every day the astronauts see 16 sunrises and sunsets. Outside temperatures are extreme. It's really hot when it's in sunlight, 250 degrees Fahrenheit. When you're in darkness at night, 250 degrees minus. So it's really, really harsh conditions. But when you look out the window, if we were on the space station, you'd see all kinds of really wonderful things. Here's our beautiful thin atmosphere that protects us. When you look out the window and you look down, you see aurora. You look down to see aurora, not up. And you also can see stars. This is actually a photograph taken from the ISS, but you can actually see stars when you're in the dark time. And when you look down at Earth, you can see all kinds of things, the ocean and things that are going on the planet. And if you happen to travel at night over a city, you can take pictures of it. And I believe if I did my map making right, I think everybody there tonight is in that little circle. So you can do all kinds of photography. So that's what it looks like. And if you take a closer look to see what it's actually made of, you can see all the modules now clearly. All these, they call them, some of them are called nodes. Some of them have been built, by NASA and other space agencies. That this sort of forward portion is mainly the US and other agencies side, whereas this part is mainly the Russian side. And there's access between all of the ports from place to place. So there's no doors and stuff like that. This is a truss. It's kind of, think of it as the backbone of the ISS. And there are solar panels. So all the modules, basically, there's a lot of communications. I forgot how many thousands of miles of wires there are, but there's a whole bunch. So anyway, it's very complicated, all kinds of things. They have radiators to get rid of some of the hot stuff that the solar panels gather. But how did all those parts get there? So in the beginning, there were two options. One was Russia, and Russia had a Proton rocket. And this is the very first module that got launched in space. It's called Zarya. It launched in November of '98. The second module launched in 1998, a month later, inside of the Endeavour space shuttle. And inside of the cargo bay, they brought the US Unity module. And when they got to space, they actually grabbed hold of the Russian module and used the Canadarm to connect the two segments together. So that's how the little baby space station started. So another module was launched. That one's called Zvezda. This is what our little baby infant International Space Station looked like. And on October 31st, Halloween of 2000, the first crew launched to the space station on a mission to get the space station up and running and make sure all the systems were working. It was launched by Russia. The astronauts were up here in the top. There were two Russian cosmonauts and an American, Bill Shepard, astronaut, and they worked together for 4.5 months. They were there getting all the systems up and running. So altogether, it took about 42 launches during that initial period of time over the years to deliver all those modules and stuff, other equipment. And this year, on November 2nd, marks 25 years that the ISS has been in operation. And not just in operation, but there have been people living there, different crews swapping in and out for 25 years. So it's been had people on board all that time. So the first crew was called Expedition 1, and the current crew that's on board the station, 7 people, is Expedition 72. So you could see there are a whole bunch of missions that have been to the space station. So how do you get supplies and astronauts there? Well, and when it comes to supplies, there's 3 options at this point. Russia has a spacecraft called Progress. There's another spacecraft called cargo spacecraft called Cygnus that was built by Northrop Grumman. And the third one is Cargo Dragon. So SpaceX has a Dragon spaceship that actually is a cargo delivery, which is separate from their crew spacecraft. So the interesting thing is, in a way, since we're going to talk about a little bit about robotics, these are robotic spacecraft. There are no people on board, so the spacecraft has to make its way to the station, and the Progress and the Crew Dragon, or the Cargo Dragon, actually autonomously dock themselves. So no intervention is needed. Cygnus still needs a little help. It doesn't have docking capability, but they use the robotic arm, the Canadarm, to grab hold of it and then bring it into a dock. So anyway, those are our 3 options today. And the interesting thing that makes the Cargo Dragon different is it actually comes back to Earth, and it can return experiments that have been all the research that's being done. A company can send an experiment up to the station. They can do the station experiment and then send it back down so that whoever sent the experiment can analyze what the result of the experiment was. So this was a big game changer for any of the groups that wanted to send research up to the space station. These 2 vehicles actually undock, and then they end up burning up in the atmosphere, probably parts of them plunk in the ocean. When it comes to crews, they're currently, Russia supplies a Soyuz spacecraft. This is what it looks like. Very reliable. It's been started to be used in 2000, and it's all the way to today. There's about to be another launch in a few weeks. Carries 3 crew members. So this is their rocket, and up at the tippy top, there's where the spacecraft is. And this is the inside of it. You can see this is not a big spacecraft. This is literally shoulder to shoulder, but it's super reliable, and they've had they've contributed a lot. It launches from the Baikonur Cosmodrome in Kazakhstan. And so that's their launch pad. And then when it comes back, it actually flies over Baikonur, and then it lands in the steppes of Russia, comes down on a parachute. And this part is where the crew is. This part is like a service module, and before it comes back to Earth, or on its way back to Earth, they actually separate. This part doesn't come back to Earth, but this is the crew part, and this is what it looks like. And when it lands on land, there's a recovery crews, I should say, with medical doctors and stuff like that. So anyway, very, very reliable. The space shuttle was a big help as well. It could deliver supplies and experiments and people. So the space shuttles were operational from 1981 to 2011. There were 5 of them, and they have a huge payload bay. You probably all know about them. And that advantage of that big cargo bay was that's where a lot of the modules got launched. And here's an example of one. This is one of the modules that got delivered to the space station. It had to be designed to fit in the cargo bay, of course, but anyway, a very, very successful, brought not only once the station got up and running, they actually, the astronauts that would be on the space shuttle mission could actually do some research inside as well. So depended on what the mission was. And I wanted to point out, this is one of the crews going to the space station. And this is Eileen Collins from Elmira, New York. So I always want to give a shout out to New York State astronauts. And she was a pilot of 2 space shuttle missions and the commander, actually, of 2 space shuttle missions. She was the first woman pilot of the International Space Station. So anyway, she's awesome. So everything's going along and everything's fine until 2004. And in 2004, President Bush announced that the shuttle program is being canceled. And along with that notice, so that was again 2004, the commitments that we had made, NASA had made to complete the ISS construction, all of those goals were going to be met and missions were going to go on as usual, but there was a final flight target for 2010. So in 2010, the missions, NASA was reviewing some missions, and here's what they were hoping would we could find some way to get people back to the space station. So there was an announcement in 2010 that about this program called NASA's Commercial Crew Program. We're going to talk about what that means. So just for historical purposes, here's the final flight. It was Atlantis. It launched and landed in 2011. And on that day, when they touched down at Kennedy Space Center on July 21st, 2011, from that day on, the only way for people to get to the space station was in the Soyuz spacecraft. That's it. There were no other options. So what ended up happening is that really curtailed a lot of the research and a lot of the activities that were going on in the, especially on the ISS. So what is commercial crew? Well, it's actually, it can be thought of as a collaboration between NASA and private companies. And the whole gist of the program, the main goal was to launch US astronauts from America and use American rockets and spacecraft. So they the deal was that the companies would design and build a crew transportation system. So what does that mean? Well, NASA's goals and their responsibilities in this program were they have very strict safety and mission requirements, and in particular because there are people on board. So they set milestones and they provided through this whole program technical assistance, awarded contracts and so forth. But the bottom line of that was NASA became a customer and a partner of the service provider. So the service provider their job was to do everything: design, build, test, deliver a whole complete crew transportation system, all the way from you need to create a spacecraft, you got to find a rocket, you got to do new spacesuits, provide life support, and all this other stuff. And not only that, but when the astronauts come back in your crew vehicle, you have to recover them from wherever they land. So it was a big, the onus became onto the service providers. And the interesting thing was the service provider retained complete ownership of everything that they built. So the that also meant that they had to maintain what they built, right? So it's not just build it, one-shot deal. That's not really what the plan was. So here's just a quick summary they spent a couple years. NASA asked companies out in the US, hey, tell us what your ideas would be for your crew transportation system. And they did eventually award 4 contracts to these companies. And then in December of 2014, they eventually narrowed down the choices to Boeing Starliner and SpaceX Crew Dragon. So from that point on, starting in 2015 all the way to 2018, the partners got to the companies got started on manufacturing and design and doing all that stuff. There were actually NASA astronauts that began work with those companies and gave advice about, because they were all seasoned astronauts, so give advice about, here, do this, don't do that kind of stuff. So in 2019, finally, there was a launch. SpaceX launched the first demo mission, no people on board, and then in December, Boeing launched. And we're going to talk about those launches. And then in 2020, May 30th, that's when the first Crew Dragon launched, and it was the first time that astronauts did in fact launch from US soil. So the two partners are, the NASA partners are Boeing and SpaceX. So we're going to start with Boeing. Boeing's spacecraft is this thing right here. It's called Starliner. They didn't, Boeing decided, well, we're not going to build a rocket. So they had an agreement with United Launch Alliance to use their Atlas V rocket, super reliable, to launch their astronauts. So that was a good thing. And they launched from Launch Pad 41 at Cape Canaveral. This is just sort of an look under the hood kind of a look at Starliner. So this is the crew cabin. There's at the bottom of the crew cabin is a heat shield to protect them during reentry. There's a service module attached, and underneath the service module is where solar arrays. So when they're on their way to the station, the vehicle can be charged, and when they're docked as well. So the rocket, the usual thing, there's a first stage and a booster second stage, and here's the Starliner. So here's the Starliner vehicle. So this part is the crew module, and this white part is the service module. The crew module, where the people are, is reusable, designed to be reusable up to 10 times. It can carry up to 7 crew members, but NASA was pretty honest right away and said, hey, we're probably only going to do 4 per launch. Their landing system has 3 parachutes, but the interesting thing is they land on the ground. They don't land in the ocean. So we'll talk about that. And there's some thrusters on the spacecraft so that they get used during reentry. The service module, this white part, has 48 thrusters on it. Some of them are in these little things called a doghouse, and they're all grouped together, and that's for basically maneuvering the vehicle as it's flying through space. Again, I mentioned the solar array at the bottom, and this part does not return to Earth. It doesn't land. It just burns up or falls into the ocean. This is the part that returns. This is their solution. This is a Boeing spacesuit. This is the inside of their cabin, which you can't see very much of it, but this is the control panel. So it kind of looks like more of the traditional fighter pilot console or interface that they're usually accustomed to. So there's dials and push buttons and switches and stuff like that. But there's some screens that tell you stuff. There's actually a joystick. So when they land on land, there's actually 5 choices, depending on what the weather is. There's a agreed upon site in Utah and California, another one in Arizona, and there's 2 in New Mexico. And this one, this White Sands Space Harbor, is the primary one where they always would really like to land. This is just an illustration. Here's the second stage Centaur rocket. Here's the Starliner. And when they separate, Starliner's on its own and makes it to the station. So here's what happens when it gets there. So Starliner is autonomous. It's meant to be autonomous, and it's got a whole bunch of sensors and cameras and stuff on board so that it knows where the docking port is and so forth. And it has a target, what it's supposed to be aiming at. And so it slowly goes into the docking port where there's locking latches. So they call it lock and dock, and they pull it in and secure it so it's attached to the station. When they come back, there's this is an illustration of the parachutes, and then just before they land, they drop the heat shield because they don't need that anymore. And then just before they touch down, they deploy landing or airbags just before they touch down. So it's kind of like a car airbag, you know, it cushions the people inside. So what happened? What's the story with Starliner? Well, here we go. We're going to start December 20th, 2019. This was the first launch of their Crew Dragon. Again, no people, Crew Dragon, Starliner, sorry. So no people are on board, except they did actually have a mannequin. They nicknamed her Rosie, and it was basically all wired up with a whole bunch of sensors and stuff, so they could tell about like G-forces and, you know, vibrations and stuff. So it's meant to be a fully autonomous flight. It's test all the systems, and they were going to deliver some cargo as well. And the plan was to spend about 5 days. So I happened to be in Florida and managed to get tickets. And sure enough, on December 20th, it launched and went on its way to the space station. So what happened? Well, not so good things. So about 31 minutes, about half an hour into the flight, just after the second stage and the spacecraft separated, all of a sudden the spacecraft was on its own, and they had a big problem with it kind of boils down to software mainly. They had this error, and they had not put coordinates in correctly. Anyway, the thrusters kept firing because it didn't actually know where it was, and it thought it needed to catch up and be someplace where it didn't really need to be. So it burned a whole bunch of fuel. There were some communications dropouts on the way. The bottom line was Starliner ended up in the wrong orbit, and because it burned so much fuel, it didn't actually have enough fuel to get to the station and safely return. So they made the decision to end the mission, and a couple days later, they did some further testing along the way, but a few days later, it actually did land. Here's a picture of it when it landed and the recovery crew and so forth. So that started this big mission review, and it took almost 7 months, but NASA and Boeing finally released this report that said, guess what? There are 80 things you need to fix on this spacecraft and with your system. So software, hardware, a whole bunch of things. So what ended up happening is they really got to work, and it was a coordinated effort between Boeing and NASA. But Boeing did, to their credit, they did all the recommendations. So it took a year and 8 months after that spacecraft landed to get to the second test flight. So it's a do-over. Let's do it again. Same thing, certification mission, if it's okay, blah, blah, blah. So, you know, same thing, Rosie's on board. Well, so this was on August 3rd of 2021. And as they were doing the countdown, a couple hours before launch, you always test all systems. Well, they detected thruster issues. So on the service module, 13 thrusters were stuck. So they managed to get some of them open as the countdown was going on, but 4 of them remained stuck, and they made the decision to scrub, because if you don't have enough thrusters, and besides that, 13 had for some reason failed, you got to find out what's going on. So this, long story short, investigation's underway. 9 months later, there was that actually did launch. So that when it got scrubbed, it didn't launch. So again, same goals. It did actually launch. It did dock. However, there were problems. More thruster issues. 2 service modules thrusters failed. There was a cooling issue inside of Starliner, which the ground team managed to override. But anyway, a couple problems. So they decided, okay, it did stay docked for a while, but they brought it back. It undocked and landed on the 25th. And after, so sort of a post review, they realized they needed to do something, make some fixes to parachute lines. And there was a big debate about some wiring harnesses. Okay, so the result of that was, had this been okay and not had problems or had minimal problems, NASA would have given them the okay to launch people. But they decided to cancel, and they actually were going to launch in July, just a couple months later. Okay, so with the thruster problem and a lot of other complicated things I won't get into, it took 2 years to work on the spacecraft and work on the service module in particular. But we have finally reached last year, June 5th, and they did in fact launch the first crew test flight, and that's Sonny Williams and Butch Wilmore. It was their target was about 8 days, and again, all systems test, but this time with people on it. So these are just a couple pictures of launch day. Here's the vehicle that gets them to the launch pad. Here's Sonny walking across the crew access arm into the white room and then going to get in the spacecraft. It did take off, and here's just a shot of the inside of the cabin. So it docked. It did dock, and it docked to the forward port of the space station. Crew Dragon 8 was already docked. So anyway, that's our second crewed spacecraft. So it was a happy day, right? They all got in there. Here's Sonny and Butch, and the other astronauts were part of the expedition that was there. So 4 SpaceX deliveries and 3 deliveries by Russia. But anyway, all big happy crowd. And I'll just take one more second and say, hey, see this person right here in the middle? That's Dr. Jeanette Epps, and she's from Syracuse, New York. She's been a NASA astronaut since 2009. So anyway, she's part of the SpaceX Crew 8 mission that was on board when Sonny and Butch came on board. And her mission was from March 4th to October 25th of last year. Okay, so while it was docked, some more issues, more problems. So before launch, there was a helium leak in the service module in one of the thrusters. Okay, they did some stuff and they decided, all right, that we got a lot of backup, no worries. Well, during docking, there were 4 more helium leaks, and then they also realized that 5 of the 28 service module thrusters failed. Okay, so now the question is, can they get back safely, or what the heck is going on with these thrusters? So this big investigation started in space. They did hot fire tests, tons and tons of tests while in space, while it was docked to the space station. On the ground, there was like incredible amount of work. They worked, I swear they were probably 24 hours a day for a long time. So to Boeing's credit, they brought in some of the vendors that sold them some of this stuff. NASA was involved. So everybody worked really, really hard, but eventually, so here's the service module. You can get an idea here with these people. Here's the doghouse where the 4 dog houses where the thrusters are. So in this service module where the majority of the problems were gets burnt up when they come back. So they didn't really have any way to hands-on take a look at it when it got back. So anyway, on August 24th, Boeing felt pretty confident that the astronauts could come back, but NASA was like, we've had a lot of thruster issues here. We still don't quite understand why. There are some things that were obvious failures or some O-rings and stuff, little gaskets. But anyway, they made the decision, NASA made the decision, we're not going to put our crew on your spacecraft. So they've got to come back. So in the meantime, they did a whole bunch of planning, like, okay, well, they're going to be on there. How are they going to get back? And so let me just finish up with this part of it. First, Starliner did come back uncrewed, all by itself. It flew itself back. It did land. Here's recovery, landing. And so everything actually did work. But the question is, what is it that's wrong? And if you look at the summary of their launch attempts and their actual launches, it's, you have to kind of question what sort of solutions can we come up with to be sure. So what ended up happening was, before they made that announcement, NASA made sure that Crew 8 was still docked to the space station. They weren't going anywhere for a long time. So they found a way to they could have put Sonny and Butch in that spacecraft when Crew 8 came back. But they decided not to do that because they'd bring 6 people back and that had never been done. So, okay, it was kind of a good idea. However, we don't, we're doing a lot of research. We're doing a whole bunch of stuff. So Sonny and Butch agreed, hey, we're here. We knew it was a test mission. We're here. We don't care. So that's why they're still there. And the long range planning was to bring Crew 9. There was originally 4 people that were going to launch, but they made the decision, let's bring them back with a 4-person spacecraft. So Nick Hague and Alexander Grubanoff launched, and that's the spacecraft that Sonny and Butch are going to come home in. So the question is, when is Starliner going to be certified to come back or to go back and do launches? And there's actually no answer to that question at this point. Still a lot of work going on, but I won't say that it's on hold for sure, because they're working like crazy to try to figure out what to do, but everything's on hold. So no launches planned. Okay, so let's talk about Crew Dragon and SpaceX. So this is the Crew Dragon, launches on a SpaceX rocket called a Falcon. They launch from Launch Pad 39A at Kennedy Space Center. They also have an alternate space, a launch pad rather, Slick 40. They could use that. So they have also, this is the crew part, and this is what they call the trunk. So just for reference, here's their Falcon rocket. It's a 2-stage rocket, got a first stage and a second stage. This illustration shows a fairing, which if you launch a satellite, you would protect the satellite as it launches. But when there's people, this spacecraft can withstand the rigors of launch, so it doesn't have one. So the Crew Dragon, same thing. 7 people. It can usually, the plan is to do 4. Their landing system is they have parachutes and they land in water. This spacecraft has thrusters on it, and when it comes to the trunk, this has no thrusters. This is just it's got a solar array on it, so it's used for power to recharge the vehicle while it's in space, even docked to the station. On the other side of it is actually the solar panel. This side is the radiators. But if you could look up into this from the bottom, you'll see that it's open. It's not a pressurized trunk. So they can put cargo and have done that, put cargo in those unpressurized bays and launch that. So this is the only part that comes back. This part does get destroyed on the way home. So this is their spacecraft. They use Teslas to take people to the launch pad. Here's the inside of it. So it's quite spacious. There's Jeanette Epps again. And here's the control panel. It's touch screen for the majority of the interface is a touch screen. And there are some buttons and stuff like that, but it's mainly touch screen. So at first everybody was like, okay, especially seasoned pilots, like, I don't know about that, but it's worked out really, really well. And you can have all kinds of information maps and stuff. So their first launch was Demo 1 that was in March of 2019. Again, no people. They also had a mannequin inside, all doodled up with sensors and so forth. So they did launch on that day, spent some time at the space station. Astronauts went in and looked around, and then they ended up it undocked and splashed down in the Atlantic Ocean, and it was retrieved by a SpaceX ship. They actually have 2 ships, and we'll talk about that in another minute. But anyway, again, full system test, and if this worked, they got approval for crew launch. And it turns out we got lucky again and got tickets to the launch. So these are launch tickets. But when the Crew Dragon came back, it was recovered in the ocean, brought up onto the ship. We actually went back to Port Canaveral and watched it come in through the port. So this is actually a picture of the that I took that is the Crew Dragon. Okay, so they got the okay, everything worked really well, and they got the okay to launch. So on May 30th, 2020, they launched Bob Behnken and Doug Hurley, and that in fact was the first American crew launch since 2011. So this is the suit up room and saying goodbye and going in their Teslas and driving up this long ramp up to the launch pad and getting in the spacecraft. And here's the Dragon breathing as it was being fueled. So it took a similar trajectory that all the crewed spacecraft takes, goes over the Atlantic. There's actually always for SpaceX and for the Starliner, there's actually military people on standby ready to go in case there was an abort. They could go, they've got aircraft and helicopters and a whole bunch of stuff. They could recover people downrange. And the interesting thing about SpaceX that you probably already know is they bring their first stage rockets back. So they have 2 of these landing platforms that they take out into either the Atlantic or into the Gulf, and they land on those barges. They've just figured out a way several years ago, actually, to come back, have that first stage come back and land at a landing site on Cape Canaveral. So, okay, so here's some launch day pictures. Here's liftoff. And 8 minutes after this first stage rocket lifted off and released stage 2 in Crew Dragon, it actually did come back and it did land on their barge. So they've been very successful. I think it's close to 400 rockets have come back so far. So on docking day, here's the inside. So you can see, actually, I guess it's this one. This is actually a picture, an outside picture of the space station. So they docked at the forward port same way Starliner did. These are just some, a picture of it coming toward the station. So when they docked, you have to do pressurization and all this stuff. Well, anyway, they finally could open the door and float into the space station. So here were the 3 astronauts that to greet them, and here's Bob and Doug. But I want to pause for a minute or a moment and say this is kind of a stark reminder that in that big old space station where there's all this incredible research labs, there were 3 people on board for years, years and years and years. So it really impacted the uh, opportunities that you could have to put research and do research on the station. So this I really like this picture as a reminder of that, of the value of the crew, the commercial crew program. So this is just a couple pictures. This is the rocket coming back into Port Canaveral. If you're ever down there and they did a launch, go down there. You can watch it roll in the port. It gets towed in by a tugboat. So we managed to get out there and see it. And you just look across this narrow waterway, and you know there's a rocket over there. It's the most surreal thing because it comes down in the middle of the port, so you're really close to a whole rocket. And look how well. Let's see here. Here, way down at the end, at the bottom, that's people down there. So it gives you an idea of how big the thing is. So while the demo two astronauts were there, they really, NASA and everybody took advantage of, holy cow, we've got all these extra hands to catch up. So they really got to work, did some spacewalks, did a whole bunch of maintenance. So really, really good. On docking day, August 1st, 2020, everything went well. They splashed down. And so the other cool thing about these 2 ships that SpaceX has is they have a helicopter landing pad on the top. So they send one of them when crews are coming back. They send one out into the Gulf. These are the target places where they're going to land, and another one is out. The second one is out in the Atlantic Ocean. So it's got full medical facilities and so forth. This is what it looked like the day that they came back. These are SpaceX people that put some cabling and stuff. They brought it up onto the deck with cables, put it in this little thing they call the nest, and then a whole crew was there to safely open the door. And here's the happy astronauts. And they actually, as I mentioned, they have a medical facility, full medical facility, and they actually have doctors, NASA doctor and SpaceX medical crew to evaluate, make sure that the astronauts are okay. So they got granted certification. So Crew 1, a long duration mission, started in 2020, and today we're all the way up to Crew 9, and these are the folks that are going to come back probably in a week or so. So living and working in space, it's, as I mentioned, it's an incredible research facility. And the reason it is because of all these weird differences between being in space in this microgravity and being on Earth. So there's in this weightless environment, there's big differences in physical and biological processes. Fire is different, fluids, all these flow of fuels and so forth. That's all different. Organisms are different. There's a lot of impacts on crew members, muscle and bone loss, because they don't use their muscles. They just float everywhere. We're not designed for that. Fluids go up into their heads because there's no gravity pulling your blood down. So people have vision issues and stuff like that. Here's a great example. Here's a flame on Earth. And look at this flame, how a flame burns in this microgravity. Without gravity, hot air does not rise. So who would have, I never would have thought that. Water and fluids behave differently. This is a drink bag. So you squirt water out of a drink bag and a ball forms. And then you can eat your, fly over there and grab and swallow the water, catch it in your mouth. And this astronaut did a really cool um, experiment in front of some kids. They had a student thing, and this is an example of surface tension. He got a washcloth soaking wet, squirted it with a bag of water, got it soaking wet, and wrung it out like you would do your washcloth when you take a shower. Well, the water does not fall down. The water, because of surface tension, surrounded the washcloth. And it actually got onto his hands, and it looked like he had jello on his hands. It was water. So surface tension is a big difference. That's for sure. So they do have some free time, although they usually are busy for 10 to 12 hours a day. If you get a haircut, you have to use a cutter that has a vacuum cleaner on it, because if you cut your hair is going to fly all over the place. It's not going to fall down on the ground like it does here. And guess what? There's no shower on the space station because water floats. So how do you wash your hair? Well, you take one of those drink bags and you put some water on your hair, and then you work it in, and surface tension lets the water grab onto your hair, and then you take this shampoo and you work that in, and then you wipe it off with a towel. So big differences in the way things work. On sleeping, there's some cabins. It sort of looks like an old phone booth, right? Well, here's another difference. So when it's time to go to sleep, what you do is you go in your little cubby here, and you get into a sleeping bag and zip yourself in, because if you don't and you fall asleep, you're going to float. And if you're outside, the station, or you leave your door open, you're going to float out into the space station. So what's going to happen? Not good things, right? So, and then if there aren't enough of these little sleep quarters and personal quarters for the astronauts, all you got to do when it's your time to sleep, just take your little sleeping bag and Velcro yourself to the wall, and you're good to go, because there's no beds, right? You float. Kitchen is different. They have ovens, food's rehydrated, and some stuff comes in cans, but they have heaters and coolers and stuff like that. But I wanted to point out this little bunch. See these little bottles? Well, let's say that you rehydrated a hamburger and you're going to have a hamburger, and gee, I'd like some salt on my hamburger. Well, if you had a regular salt shaker and you held your hamburger out and you shook your salt shaker, that salt is going to go everywhere. It's not going to fall down on your hamburger. It's going to float everywhere. And so that'd be a bad thing, right? Get in electronics and so forth. So they invented liquid salt and liquid pepper, and some of the other spices that people use. So you can, mustard comes in a container, so you just bring your mustard container, and that actually works, but not regular powdered stuff. So most of the meals are in, you use a spoon, because these are in the dehydrated bags or rehydrated bags. Don't let go of your spoon, because it's going to float. And if you're talking to somebody and it floats away, you're not going to know where your food is. So this is kind of a kitchen area. They get together, it's social time. You can use tortillas to make pizzas, so that's a big treat. And if there's a resupply ship, you can get fresh food, and even occasionally you get some ice cream. I already mentioned exercise is important. There's exercise gear on board, so again, prevent bone loss and muscle loss. You got to do maintenance, so there's no Maytag repairman that's going to come and visit your space station. You have to do it. All the crew members are trained on all on the system. So they actually do repairs, preventative maintenance, and so forth, including making sure that the bathroom works just fine. And if there, you actually have to do maintenance outside as well. So here's you flow down into space, you tether yourself. You can use handrails that are all along the ISS, but you're tethered, or you can have somebody operate the Canadarm and move you around to a place that's far away, for example. So I thought this was kind of a fun thing. Like, where is Sunny Williams? Sunny Williams did 2 spacewalks. Like, where is she in this picture? Well, you probably can't see her, but there she is. And she was doing maintenance on the docking port, actually, doing some upgrades. So this kind of gives you an idea of just how big the space station is compared to people. A lot of science and research. There's tons of really high-tech equipment. There's microscopes, there's glove boxes, just all kinds of research gets done. Here's they're trying to grow plants in space. They grew lettuce, radishes, and so forth, so that maybe on future space missions we can actually grow food on our way. The crew members are actually medical experiments themselves. They draw their own blood. Eyes change, so they're constantly monitoring, and they're trying to learn more about what the effects are of microgravity on people. So they actually are an experiment. This is just some research that's been going on. Lots of nasty diseases that we have on Earth. There's all kinds of research going on. Actually, robotic surgery, the eye tracking device. This is how laser surgeries, that came from the space program to be able to do laser surgeries. And so the experiments are done, are sent by NASA facilities, pharmaceutical companies, universities, and so forth. So that's how the stuff gets there, and some of it comes back. And just a reminder, there's a whole bunch of spin-off products like the cameras we have in our cell phones, wireless headsets. How about cordless drills? You can't have, if you need a drill outside of the ISS, you can't run an electrical cord, right? An extension. So Black & Decker actually invented cordless drills in the early space program. So finally we get to robotics. And so here's what some people think of as robots. And of course, we all love robots in sci-fi movies. But there's also other examples of robots and robotics. Here's the Perseverance rover doing awesome science on Mars. And here's what we use on Earth. Look at the Roomba. That thing's cleaning the floor. It's a robot, and it can give your cute little puppy dog a ride and entertain it. So, that's kind of a good thing about robots, and a good example. You can say that we already mentioned this. You can think that there's robotics involved for sure in all these spacecraft getting to and from the space station. Even the rocket that launched and comes back, there's robotics involved in that. So there's a lot of good things that robotics can and does do for humans on the space station, and it lets people focus on what they're really good at. And so robots can do dangerous things like send a robot out and do a repair on the ISS, right? Instead of taking a person out, anything could happen. A micrometeorite could hit them. So, but that's okay for a robot. So, but they can do all kinds of stuff, move cargo and do monitor systems and so forth. So robotics are really important. So here's some examples. There's 3 robotic arms. We're going to talk about the Canadarm and these other 2. So let's start with Canadarm. Installed in 2001, and I don't know, the space station couldn't have been built actually without the robotic arm. But actually it's part of a 3-part system. So here's Canadarm, and there's another robot that's called Dexter, and we'll talk about that. and they can be, so Canadarm can connect to Dexter, and Canadarm can be connected to this mobile base system. And so we'll talk about that in a second. So the Canadarm is basically two long arms with an elbow in the middle and flexible gears and stuff, so it can be move around. And there's a thing at the end, both ends of the Canadarm has the same ends, and it's a thing called latching end effector, or LEE. And what it's used for is to attach itself to the space station using these right here, these grapple fixtures, and some of them are outside on the station. Some of them you can attach to a big old, I don't know, a new cooler unit that you want to put outside. You can attach that cooler to one of those things, and the Canadarm can move it around. So this is kind of a zoom in picture, and I'll just show you. So here's the thing that that it basically connects to. You can see this little shaft in the middle, which is sort of, here's how you aim it. And so here's a little movie of how it works. There's some metal straps that come out, grab it, pull the thing in, and then those four ends are connectors for power and communications and stuff. So it's a really cool setup. So that's actually how it works. And actually, Canadarm can walk itself along the ISS to different places by itself, and be like an inchworm, go arm over arm over arm. So Dexter's really cool. It's a space robot, and they literally call it that. And it's got two arms and there's a bunch of cameras on it. That's all the little blue things. Well, these arms have a whole bunch of joints: a shoulder joint, elbow, and wrist joint, and they have this wide range of motion. If you were Dexter, you could put something on the end of your robotic arm and put your arm behind your back and spin it. We can't do that, right? So it's got all kinds of really good capabilities. And there's a tool holster, so you can put some stuff on the ends of it, and it's very precise. So this has made a big difference. This is relatively new. The mobile base system. So here's Dexter and Canadarm, and this is the mobile base system. Well, it's a movable platform, and all along the truss of the space station, it's like there's a little railroad track out there, and this cart, it's kind of like a cart, it can move along the truss rails, and there are places along the way that it can stop. It's got those things that I showed you earlier with the power and the gnomon in the middle of it. So it's a really cool way to have robotics used by ground station people on the ground to do work outside the ISS, and it doesn't need a person to be outside. It's all done. It can be done from the ground. Another example is the this is the Kibo module. This is a second arm that we're going to talk about, and it's a similar to the Canadarm. And this is a zoom in. Outside of that Kibo module is a platform, and you can put science experiments out there and expose materials to the harshness of space to see how they deteriorate or stand up. There's 12 places you can put experiments out there. So you start on the inside. Here's the Kibo module. You start on the inside, you open this door, and there's a slide table, and you hook your experiment on there, and then you slide it into this tube, and then you close the door and depressurize, and you slide it outside where the arm grabs it. There's a little door over here, and it places it outside. So this is all done from the ground robotically. So that's another really cool example of robotic control from ground teams. the European Space Agency built an arm for the Russian segment. They didn't have one that was so flexible. This is how big it is. It's pretty big, and it can be used to transport payloads or people, cosmonauts and so forth, do deploy stuff. It's programmable, so it can actually work all by itself, and it can do maintenance and so forth. It's remote controlled. It can be remote controlled from inside the space station, or they figured out a way, ESA figured out a way to have a remote control system outside. So if a cosmonaut goes out to do work, they can actually manipulate the arm by themselves. Or again, the ground teams can. So anyway, that was really cool. This is just a picture of what it looks like. So gosh, I'm going over time here. Sorry about that. So I'll try to talk quicker. But anyway, there's been other robots on the space station. They've been replaced by a new robot called Astro Bees. There's actually 3 of them, different colors. They have a whole bunch of cameras. They can be remote controlled from the ground. You can write programs for them. They have touch screens and microphones and stuff, a whole hazard cams and so forth. They have an impeller. They're driven by air, so there's no fuel involved. They just move air around in these little, there's 12 of these nozzles that you can adjust to have it navigate. So here's just a couple of examples. They programmed, wrote some algorithms to pretend that this guy was a tumbling satellite and this guy was the chaser. So for the future, maybe we'll have a robotic, let's fix a satellite out in space. So that was a fun. There's actually a video that you can watch, and they attached on the little, the Astro Bee has a little robotic arm, and they've been attaching stuff to it to see what it can do. There was one thing called Gecko Gripper, so that it could hop, and then there was another one that it would launch itself into motion. And both of those were very successful. This was a really cool one. Sonny Williams was part of this experiment. They have invented it's called Reach, and it's basically an accessory to Astro Bee, and it's got 4 arms, and at the end of the arms are gecko-like, the little pads that geckos have. It has gecko-like ends on it, so it can grab things. So this, again, if they could figure out how to make these arms work successfully, then it could actually do a lot of work outside as well. So I'll play you this video.
We're going to try and get Astro Bee to approach it. If it misses, that's okay.
So that's pretend
this is all part of what we're
satellite.
figuring out today. Looking good.
Is better?
There we go, Sonny.
So anyway, that was successful, and the person you heard talking in the background to her was on the ground actually doing the experiment. There's another thing they tested, SoundSea, that listens to sounds on the space station. This is a separate experiment called Space Mira. It's a surgical robot. It's a small miniaturized robot, because what if somebody needs surgery in space? So this was an experiment. This is the device, the actual robotic device, and by this company, independent company, and it has 2 arms that are flexible movement. It had grippers and it had scissors on the other end. And the experiment was on the ground. They ran 2 experiments. One was pre-programmed and the other was actually done by people. So what it was an experiment to see if from the ground they could actually control this robot and have it do things. And they had this little test stand that was part of the experiment, and it has rubber bands. And so they used the gripper to put tension and the scissors to actually cut it. And so there was a pre-programmed one to let it do it itself. But on the ground in Nebraska, there were some stations, and these are actual doctors who were remote controlling this robot from space. And the interesting thing was there's a little time delay in communications, almost just not quite a second. So if you're a surgeon, that would make a big difference, right? But they figured out a way, the surgeons that were operating it could anticipate that difference. So anyway, that was really successful. Another independent experiment was a metal 3D printer, never been done in space before, and this was very successful. They wanted this 3D printer that was controlled by Earth to actually make this configuration of build this. And so anyway, long story short, it actually worked. And here's actually there's Jeanette Epps. This is the case that it was in, and it actually did work. So that's going to be returned to Earth so they can evaluate it. This is just sort of in reverse. This was one of the astronauts on the space station. This is called Analog 1, a European Space Agency experiment. And there was an astronaut who was remote controlling a robot on Earth. And that worked really well. And this is to simulate control of a rover on the moon. If you're orbiting the moon, you could actually remote control. So anyway, that was successful. So the bottom line is robotics plays a really important role in now and in the future, and there's a ton of experiments going on, and those innovations that they come up with might lead to new products for us on Earth. So anyway, this is just some food for thought. If you are a designer of a robot or you're doing AI writing programs, just keep in the back of your mind this guy. Remember this movie, 2001? So there's Dave, and he's telling Hal to do something. And what does Hal say? I'm sorry, Dave. I'm afraid I can't do that. So anyway, so be careful what you write. So just to wrap up, here's what's going on. Here's the current configuration, all the spacecraft docked to the station right now. These are the people that are on board, the Expedition 72 crew members. Tonight at 7:03 p.m., SpaceX launched Crew 10. So just as we were doing the setup for the meeting, it actually did launch, and they're well on their way. They're going to dock tomorrow. I was hoping that they were going to launch. Well, they tried to launch Wednesday, but it got canceled, and I was hoping to plunk some pictures. But anyway, they're on their way, so things are going well. And what that means is once they dock, and there's a handover period, it's usually about 5-ish days where the new crew gets acquainted with the space station and procedures, and they do drills for emergencies and all kinds of stuff. So the Crew 9 crew, once all that stuff is done and they do the handover, they're going to come back home in the Crew Dragon, and that's currently targeted for around the 19th, but it's probably going to be pushed back maybe a little bit. But anyway, they are coming home, and no, they were not stranded even for one split second. But anyway, we won't go there. From a Soyuz standpoint, there's a launch coming up April 8th. Two Russian cosmonauts and Johnny Kim, he's actually a medical doctor, astronaut. So he's going to do a long duration mission. And the astronauts that are there right now that came up on the Soyuz are coming back sometime in April, probably sort of close to then. And that's Don Pettit, NASA astronaut. So anyway, lots of information online on the NASA website and the US lab. And I have to say, tell you that there's actually a Lego model of the ISS that you can build. So I, of course, had to buy one because who wouldn't like a ISS Lego set? So anyway, thank you very much. I apologize for going over. I can't help myself sometimes. But anyway, if anyone has any questions, I'll do my best to answer them.
Thank you, Carol, so much. So let's get the lights on in the room. We can take questions. If there are any questions out here.
I have one. Do the crews train on both the spacecrafts? You know, whoever's flying these things and commanding the missions? Yeah.
Do you-
with
are
Starliner and
Well,
the
The question is,
typically so for example, SpaceX, if you're assigned to a SpaceX launch, you typically train only on a SpaceX vehicle. There is training if you are going to launch on Soyuz. There's actually a whole year worth of learning the vehicle and what to expect, which Johnny Kim just got finished doing. So they typically don't do training on both, because the training for the Soyuz is done in Russia, and the training on both Starliner and SpaceX is done here in our country. So so they don't typically do that, and probably in the future, if the Boeing gets rid of all the problems and they start launching, then people will, I'm quite sure, be cross-trained, because they're going to alternate a SpaceX launch and a Boeing launch. So so normally I think they're not really trained.
With so many component parts in the ISS and a 500 Fahrenheit degree fluctuation temperature, how do you keep things from leaking and bleeding? And
Well, it ain't easy, is what is my sort of generic answer to that. A lot of the components that are there because they learned lessons from the early space station, what sort of hardening they need to do. Don't forget there was the Mir space station. We learned actually a lot from them, because some NASA astronauts actually went on board that space station. We learned some stuff about space stations from Skylab. Remember Skylab, long time ago. So there's a lot of things that, from a materials standpoint, you have to do radiation hardening, you have to do micrometeoroid protection. So they have a lot of the stuff that's outside is actually hardened against impact. I won't say they're impact resistant, because if they're always having to move the vehicle up and down, because it's not there's debris in the way. There's been a lot of satellites bashing into each other, so there's a full-time tracking system and people that are doing nothing but looking to make sure that the ISS stays safe. So there is, but to your point about leaks, there actually is a leak in one of the Russian modules, and it's been leaking air for several years, and it's actually gotten worse over the past year or so, and they're monitoring that. They did try to do some fixes for it, but this latest leak, they're not really 100% positive where it is. And I'll just mention too, along those lines, one of the experiments I didn't talk about was cold welding. They actually had an on-station cold welding experiment that was just done. I haven't heard anything about the results, because I'm not sure the results have been returned back to Earth yet. But that's one of the next step sort of thing. To your point, you probably are going to get hit by something, or maybe there is going to be a fatigue failure, right? The ISS is moving all the time. Those solar panels are constantly in motion, trying to grab as much sunlight as they can. So you would think that a lot of the components would wear out, but they actually do bring up spare parts. And they do have some stuff on board that to do preventative maintenance. So a lot of the spacewalks are not just for installing new stuff. It's actually either repairing or servicing, I would say, some of the stuff that's already outside. So, but it's not easy to anticipate everything, that's for sure.
We have a question on the Zoom around why was the shuttle program canceled in 2004?
Yes, that so I'm trying to remember the cost per shuttle launch. It was something like $450 million every time they launched a shuttle. And then they had to fix them when they came back. So after the second shuttle was lost, there was a lot of discussion about, is this the right thing the right vehicle to have? So in the meantime, so that question still remains really, or remained even at that point. But there was a big push to go back to the moon, and there was a program called Constellation, and there was a lot of work done. It's sort of like the precursor to Artemis. Instead of going to the ISS, let's send people, through using a Soyuz. They really wanted to go back to the moon. But that program was actually canceled because the costs and the technical issues were like astronomical. So you know what I'm talking about. And so a lot of it was actually money. NASA has a pathetically small budget in the overall scheme of things for the national budget. And to the point where science is, even before all this latest stuff that's going on, their budget never really got funded properly. So last year, there were some missions that had already been approved, work was already underway, but they got canceled or actually put on hold because there wasn't enough money to fund it. They had to divert money to other projects. So really, I think back to your original question, I think a lot of it was a commitment of money, and now we're down to 3 space shuttles. So what happens to if one of them? So what are we going to do next? What's our big project? And the decision at the time was actually the administration at that time really wanted to go back to the moon. So it was sort of a combination, really.
So on the Zoom, Carol, do you have time for another few questions or?
Oh, sure.
Great. So we have a couple out there. I think there was another hand in the room. Yep.
Hi, first I want to say thank you for inviting us. It was very educational. I have very little knowledge about science, but I was just curious. In space history, was there ever a time where astronauts as a team had to manually find their way back to Earth?
I'm not aware of that, but I do remember in the Skylab missions, there was a problem with Skylab, and when it launched, something got damaged, and the astronauts went on board to try to put a fix, and they ended up putting sort of like a thermal blanket outside, as it turned out. But in terms of coming back, I guess I don't really remember there being any kind of an issue where all systems failed. There have been issues with launches. I'll give you an example of that. There was, in fact, I think Eileen Collins, during her mission, they launched, and the darn space shuttle was, oh, actually, it was one of the Apollo. Sorry, I think it was the Apollo 14, I think it was. When they launched that mission, they left the launch pad and they went through clouds, and it got hit by lightning, and all the systems went down. So they were trying to figure out, should we go back, abort this or what? And they figured out, actually the astronauts on board figured out a way to reset the systems, and they all came back to life. So it sort of short-circuited the spacecraft and the control. But there was a similar thing that happened on the space shuttle, and I'm kind of at a loss to remember what that one was, but that wasn't something, that was another let's reset it solution that worked. So they didn't actually have to manually control, but the spacecraft do all have, that's kind of like the mantra of safety. You got to have a way back if all systems fail. So the technology should be built into all the spacecraft, but I'm not really aware of any particular mission that had to figure out a way to come back, other than Apollo 13, right? That was a bad thing, but there was a whole bunch of thousands and thousands of people involved in getting those 3 people back safely.
There's a question in the Zoom, just for your thoughts on the continuation of having female astronauts at NASA, and what what to do about NOAA given cuts these days. I can understand where this question's coming from.
I most certainly do, and I am very personally, I'll just say, speaking for me personally, I'm like crushed that we're in the situation that we're in. This services that a lot of these agencies are providing are literally life-saving services. They can save lives. So in the case of NOAA, there are people that have been let go that are key people in storm prediction and interpreting the data. They do such an awesome job. So actually in the weather community, TV reporters, people are really freaking out about it. It's really not, it's a really serious situation. So, and in terms of letting women go, I don't know how to politely say it, but that's a huge mistake. The chief scientist of NASA, a woman, was let go just last week. So what's the sense of that? What is the point of that? There's a whole, it's to me, it kind of boils down to these decisions are what I call a brain drain. What people actually bring to the table. Everybody has their own skills, and no matter what job you work at, some people are good at some things, bad at others. But when you're a team, you can make life really a good place to live, and so these kind of, to me, they're just random decisions that make absolutely no sense. And I'm really afraid for the NASA budget in particular, because there's a lot of chatter about the possibility of the budget even being cut further than it is. And I just can't imagine it. When you think about all the science, you're astronomers, you're techie nerds like all of us are. And, it's just a really sad situation. And I don't understand it at all. I really don't. I hope it changes. I really do.
Space station.
So one more question in the Zoom is around if you have any details you can share on how the ISS deals with space debris.
Space debris?
Yes.
Okay, so there actually are hardened surfaces on the outside of the station. Even the cupola, that's the place that astronauts love to go because it's got windows and you can look down on Earth, and it's just this really cool place. But that's actually, those windows are glass, many, many layers. I forgot how many layers there are. And actually there are on outside of all the glass, there's actually well, here, let me do it this way. So here's the glass. There's actually covers that they open when they want to use it. And when they know there's debris coming, they can close it, and that actually protects it. Now, some of the debris, they don't really know necessarily. You can't track all the little tiny stuff, and tiny stuff can be just as dangerous, of course, as the big stuff. So anyway, in general, there's a whole bunch of people that their job is to check the debris field. There's a it's actually a military group that tracks space junk. And so it's not just for the ISS, it's for other satellites. There's how many thousands of satellites are there now? And if they get hit by space junk, they're going to be decommissioned. And, you know, there's occasionally like a satellite that was launched a long time ago, and then it's at its end of life, and then it stops working and they can't control it to bring it back down. So a lot of those things are on a trajectory and they just bonk into something that's actually working. So creating more debris. So it's really a big problem. And for the space station, because there are people, it's one thing to lose technology, which is that's serious. Our GPS that we rely on every day to get from place to place, if that GPS satellite network goes down, we're going to be back to paper maps to navigate, right? Which, by the way, I love paper maps, so I don't know how sad I'll actually be to not use my GPS, but there's a lot of things that are up there that are really critical, including some Defense Department stuff that we don't know about. So it's really a big problem, and there is a whole tracking system, and it's an international effort. Those agencies do share information with NASA and the space agencies. They all have their own stuff, but that's a really good community that shares information. So trying to keep the ISS safe is, so far 25 years, I'm knock on wood, everything's going to be okay until the theory at the moment, or the idea at the moment, is they're going to decommission it or in the early 2030s. So we'll see what happens. But back to a previous question, things are aging, and you can't expect stuff that gets hit by radiation all the time, in solar storms, right? We're in solar max right now. So lots of things can happen, but they make it as safe as they can. By the way, if there is a solar storm, and you're in the ISS, there actually are sort of safe places that have more protection than others, and the astronauts actually go there. So to make sure that they stay out of the radiation zone. So there's lots of juggling balls in the air about how do you keep people safe when they're in this really environment that's trying to kill you all the time. You can't breathe in it. You're just going to float around, So anyway, it's a big and then very important issue. It really is.
Carol, I want to thank you so much.
Oh, thank you.
The ISS and what's going on up there. I know a lot of us at our star parties, when we have a flyover, we like to wave.
Yep.
Going over. So thank you so much for taking the time. Hope to have you back again soon.
Thank you. It is my pleasure. Thanks so much. Wishing you all clear skies.